if the slope of j is -3/2, what would the slope of k have to be if it's perpendicular to that? We're talking opposite reciprocals here. What's the opposite reciprocal of -3/2? What's the opposite of -3/2? Yeah, the opposite reciprocal would be +2/3, because if that's negative, you may need to make it opposite, which would be positive, and then flip it over. So +2/3 should be the slope of line K if it's perpendicular to line J. So let's find out. Slope of line K equals the slope of K. First of all, we need to find line K. Here it is right here. That's this one that's going up to the left. So let's see, I see a point right here. And then I see another one on the y-axis right there. That would be the point. Well, we don't even need to know what point that is. We can just count up and over. So let's see, 1, 2, and then 1, 2, 3, 2/3. So up 2/3. Are they perpendicular? -3/2 and +2/3. Are those perpendicular? Yes, because they're opposites. One's positive and one's negative. And they're reciprocals. They're flipped over versions of the same fraction. So, yes, J is perpendicular to K. Or you can just write J and then the perpendicular sign and then K. Because the slopes are opposite reciprocals of each other. Let's try 3A together down here, and then I'll have you do 3B on your own. Then we can move on to problem number 5, the very last one. Any questions about that before we look at the last two on this page? All right, so line H. So we need the slope of line H. So this is A. So slope of H. And we need the slope of L. So let's see, line H. Find a couple of points on there. Just count from one to the other, and then tell me what you get for a slope for line H. I think I actually see 2 points on line H. Yeah. Although I do see 2 points on line L. So maybe we should figure out the slope of line L first. Anybody figure out that one? The line L? There are definitely 2 points on L. So just look for where the line goes through exactly like the corner of a couple of the little gray grid lines. So like on L, I see one right here. That's a nice solid point. So that's the point 3, 2 right there. And then there's another one right down here at 1, -3. So if we count from here to here, that's going to be 5/2. So slope of line L should be 5/2, 5/2. And I don't know about you, but I don't know if we can actually figure out the slope of line H. Because I don't see two exact points. I see one point right here. But I don't see another point on this line that goes exactly through a corner of those gray ones.
Wait, how is L?
With that, how's it 5? So to get from this point on L up to here on L, you have to go up 5/2.
Oh.
Yeah. So here, what do you see? Right here? Maybe. Even if it is, let's see, that's down to n/3.
Yeah.
Which the reason why I don't necessarily think that's quite exactly true, because if we did that, I mean, we should be able to go left 3 and then up 2 and go exactly through a corner there, but that's not the corner, that's the corner there.
Oh.
So yeah, I'm kind of under the impression that there's only one point here. Either way, if this is 5/2, this one should be -2/5. We're just finishing those. All right. So if this is positive 5/2 for L, H would need to be -2/5. So that means if we go from this point here, we should be able to go down 2 and over 5 to get to the next point, which clearly isn't happening. Or we should be able to go up 2 and back 5 and get to the other point. So it would have to be here. So if the slopes are perpendicular, you'd have a point here and here, which isn't true. So like, we don't actually know the slope of H because there are 2 points on that line for us to use, but we know they're not perpendicular because we know the slope of L, and using the 1 point from the slope of H, we can tell that it's not perpendicular. So for A, we can just say not perpendicular. That's kind of a weird one. It's always good to get 2 points. But if we don't, there's a way we can figure out the answer if whether or not they're perpendicular, even if we can't figure out the exact slope of both lines. All right, for part B, I want you to do that one on your own. Figure out the slopes of K and T, determine if they are perpendicular or not. They need to be opposite reciprocal values. Say 2 minutes for that one. They already know the slope of line K. So what's the slope of line T? Anybody have it? What's that? So let's see, from T, let's see, I see a point right, let's see a point here on line T, and if we go down 1, 2, 3, 4/1. Yeah, looks like -4/1 or just -4, which is definitely not perpendicular. So not perpendicular. So neither of those, for example 3, are perpendicular. Although J and K are. All right, any questions there before we look at the very final problem, example 5? Cool. Turn the page, go to the page after that, because I messed up on my printing. And we're going to this one right here. So this one is talking about an architect, landscape architect designing a yard. So a landscape architect is designing her yard, which will have a walkway leading to a shed. She wants the edges of her walkway to be perpendicular to the back of the house. Can she continue using her design shown below and add the shed, or will she need to revise the design first? So the walkway is this gray rectangle. And then the edge of the house, you can see the roof of the house here. There's the edge right there. So basically, are those intersecting at a 90-degree angle or not? And so that's what we need to figure out. So it says that the line representing one edge passes through 0, 5, and 1, 1. So 0, 5, and 1, 1. And that's for the walkway. So I'm going to go ahead and highlight those here in just a second here. So the 0.05, that's this one right here. And then the 0.11 is right here. So from that, we can figure out the slope of the walkway. It also says the line representing the other edge passes through the 0.14 and 0.7. So 1,4 is here. That's weird. 0.7 is up here. Doesn't seem to make sense, does it? 1,3, I think, is what they meant to write. Shouldn't be 1,4. It should be 1,3. Cross out that 4, make it a 3. That appears to be a typo. So 1,3. That's definitely 1,3 right there. Okay. So 1,3 and 0.7. All right. So first thing we need to do is first of all, she wants her walkway to be perpendicular to the house, but if you're talking about two separate edges of a walkway, it says right here, well, first of all, we'll talk about this. Assume that the edge of the roof of the house is parallel to the back of the house, meaning, as a lot of you, I'm sure, are aware, if you've ever looked at a home, the roof of the house extends a little bit further than the edge of the house, right? And so what we're saying is that the wall of the house is going to be parallel to this one, but like, a little bit set back. It just says to assume the edge of the roof of the house is parallel to the back of the house itself. So we don't need to worry about figuring out where the wall of the house is underneath here. We're just saying it's parallel to the roof line there. So first thing we want to verify is that the slopes of each edge of the walkway are parallel. Because if you're making a walkway, you don't want the sides of the walkway to be kind of like moving around and maybe crossing each other at some point. They need to be parallel to each other. So we're going to start with that. And then we'll determine if something's perpendicular or not. So first thing we're going to do here, let's just find the slope of each edge of the walkway. So we'll say left edge. And we'll say right edge. And we're talking about the walkway here. So the left edge of the walkway and the right edge of the walkway. So if we look at the left edge, we're going to use the points 0, 5, and 1, 1. So to get from this red dot down to that red dot, what are we doing? How far up or down? How far over? Yeah, -4, 1, which would be -4. So the left edge has a slope of -4. So m equals -4. Now the right edge of the walkway should be the same slope because one side of a walkway should be parallel to the other side of the walkway. So again, we're using 1,3 and not 1,4. I don't know why I said 1,4. That should have been a 3. So if we go up here at 0.7 down to 1,4, how far down, how far over? Down 4 over 1, yeah. So again, the right edge has a slope of -4. So we can say that, let's see, the edges, write this down, the edges of the walkway are parallel. That's good. That should be true of a walkway. Now, that's not actually the question being asked in this problem, but that is something that needs to be true of a walkway. So the thing we're actually trying to figure out is she wants to make sure that the edges of the walkway are perpendicular to the roof of the house or to the side of the house, the back of the house. So we know that based on the left edge and the right edge, those both have a slope of 4. So no matter what, we have a slope of 4 for the walkway. No matter where we check on the walkway, it's a slope of -4, which is good. So now we need to figure out the slope of the roof. So let's see, slope of roof edge. We'll just say that roof edge. And so we need to find 2 points on that roof edge that we can use to calculate the slope of the roof edge. So where do you see points for the roof edge? So this is our roof edge right here. What are a couple of really good points that you see on there? 4 and 1. Okay, what else? Check to the left. There's a really good point that I'm looking at. 0, 0, yeah, right there. So what would the slope be to get from this point over to that point? 1/4, 1/4. Good. So the slope is, so m equals 1/4. So the walkway has a slope of -4. The edge of the roof has a slope of 1/4. Are they perpendicular? Yeah, because they're opposites and reciprocals. And now we did say -4/1 earlier, which you can keep the ones as denominators here. That actually might make it easier to figure out opposite reciprocal if you write that as a fraction, because the opposite of -4 is 4, and the reciprocal is 1/4. So -4/1 to +1/4, that's perpendicular. So we can say the walkway is perpendicular to the back of the house. Let's see. Can she continue using her design? So she can continue to use her design. She doesn't need to redesign anything because she has everything mapped out the way it needs to be. So that's our answer for the question. Now, before we continue here, it never told us in this problem to determine if the left edge of the walkway and the right edge of the walkway are parallel. Why did we do that? What was the point? Okay. Yeah, I mean, it matters for 2 reasons. The first reason is what I mentioned already. 2 sides of a walkway should be parallel to one another if you're building a good walkway. The other reason is because there are 2 edges to the walkway, if the left edge and the right edge were different, one of them might have said that, yes, it's perpendicular to the back of the house. However, the other one might have said that it wasn't perpendicular to the house if those 2 were not parallel. If they weren't parallel, then they both wouldn't be perpendicular. And so it's necessary to know that both edges of the walkway are parallel, because that means they're going to have the same relationship between the back of the house. Otherwise, it could kind of mess things up. So that was why we needed to do that, even though it didn't tell us we needed to do that. All right, the very last part here. The architect wants the front of the shed to be parallel to the back of the house. If one corner of the shed is at 0.5, can the other corner be at 3 and 6.5? Explain. So we actually have to use the slope formula for this one because we're given coordinates. We've got an x1, y1 here and an x2, y2 right there. So we have to use the slope formula that we did on Thursday. So x1, y1, x2, y2. I want you to use the slope formula given those coordinates to determine if that slope is parallel to the back of the house, which we already know the slope of the back of the house is 1/4. So basically, if that turns out to equal 1/4, the answer is yes. If it's not 1/4, the answer is no. So take a moment, work through that real quick, use the slope formula. We wrote that down on Thursday. So go back and check that if you need to, apply the slope formula and decide, is that going to work? Let's check it out, see what happens. So let's see, slope M, let's do it up here. M equals, so y2 6.5 minus y1 of 5 over 3 minus 0. So that's going to be 1.5 over 3. What does that equal? What's 1.5 over 3 equal? That's what we get as a fraction, right? What does that equal though if you divide it? Or if you simplify it, for that matter?
0.
Wait, 0.5? Yeah, should be 0.5, right? Yeah, which is 1/2, right? 0.5 is the same as 1/2. So the slope is 1/2. So is it going to be parallel? No. So we're going to say not parallel because slopes are different. Cool. So that part would need a redesign. If the shed is going to be parallel to the house, it cannot have corners. The front of the shed cannot be at those points on the grid because it wouldn't be parallel because it would have a slope of 1/2 as opposed to 1/4 because 1.5 over 3 is 0.5, which is 1/2. All right. So that's all I got for you for this entire unit. So we are done with this unit.